Hi everyone, today we will talk about digital signature. This picture describes the process of asymmetric encryption. So why do we need digital signature? Here is the problem. Because public key can be made known to anyone, so Eve can use public key to forge the content which is sent to Alice by Bob originally. For Alice, she will never clarify whether this content is sent by Bob or others. The most vital problem focuses on how to prove Bob is Bob. The easier way is to let Bob write a handwriting signature on the content. This is the basic idea of digital signature. Generally speaking, using private key, which is generated by Bob himself as the unique signature, and Bob uses his private key to compute a signature for the content, sending both signature and ciphertext to Alice. Then Alice will use Bob's public key to verify the signature. The main usage of digital signature is network communication protocol. HTTP protocol has some security shortcomings, like plaintext transmission, which cannot verify the identity of the communication of the message. To improve security level, HTTPS has been developed. Basically, HTTP is the combination of HTTP and SSL. The message is encrypted by the SSL layer and delivered to the TCP layer for transmission. SSL mainly use RSA and ACE to encrypt. ACE is first interacted by RSA and then the message is encrypted or decrypted by ACE. This picture describes 4 steps process of HTTPS, very similar with TCP three-way handshake, except it contains the transmission of encryption algorithm and encryption-decryption process. Next section, Jialiang Cheng will talk about 4 steps of.
Thank you, Tianqi. So this is Alex. Now I'm going to talk about how digital signature works. Digital signature, as public key standards, consists of 4 operations. First is the key generation, then key distribution, key signing, and the key signature verification. So next, I will discuss how these 4 operations implement. Firstly, let's talk about key generation. In general, key generation has 2 phases. The first phase is to choose the algorithm, like DSA, ECDSA, or RSA. The second phase is to compute the key pair followed the algorithm standard. You can see there is an example of RSA digital signature here. Secondly, is the key distribution. After generating the key pair, we got the public key and the private key. The sender should send the public key to the receiver through a reliable but not necessarily secret way. That is, the public key could be known to the public and won't affect the authenticity of the signature. As for the private key, the sender should keep the private key secret. The disclosure of the private key would directly affect the authenticity of the signature. Thirdly is the signing. Same as keys generate. Different signing algorithm has different signing method. It's a little bit like encryption algorithm, but use the private key to sign and use public key to verify. Also, since the length original data usually is very long, we use hash function first to get the digest of the original data. Then use send function to generate the signature. Then the sender would send both the original data and the signature to receiver. The last is verify. After receiving the data and signature, the receiver should compare the hash value of the document with the description value of the signature by user signer's public key. If those 2 values are the same, then we can say that the document has not been tampered with. That's all. Thank you.
Here is several commonly used digital signature algorithms. They are DSA, ECDSA, and ICPSS. DSA is based on the difficulty of computing discrete logarithm and 2 schemes, which will be shown later. The most important characteristic of DSA is that the computationally demanding task does not depend on the message to be signed, and thus can be done ahead of time. I'd like to introduce all the implementation detail, which takes me really long time to figure out. However, due to the time limit of the video, I have to just list them on the slides. You can pause the video to check the details, and most of them are available in chapter 14 of the textbook. Here's the first scheme. And here's the second scheme. Here's the implementation of DSA itself. And for this one, ECDSA is suitable for key with smaller bit length due to the advantage of elliptic curve cryptography. Here's the implementation detail. ISA PSS is one that ISA Laboratories recommends as the most secure of ISA scheme. Actually, ISA-based schemes are widely deployed in many applications, including financial applications. However, it has not been possible to develop a mathematical proof that the signature scheme is as secure as the underlying ISA encryption or decryption primitive before this algorithm. So for this algorithm, it's able to show that it's secure closely related to the skill of ISA's algorithm because it introduced a randomization process. But I have to say that compared to its low computation requirements, the whole procedure is apparently complex. You can see that it needs you understand and design a mask generation function, which is a helper function. And this one is the one is currently used. And here's all the parameters. And for sign step, you can see that although it looks a little complex in the diagram, it needs 12 steps. And for verifying, also it needs 16 steps. And that's all. Thank you for listening.